Pre-AP Precalculus, free response practice number 46. Consider the function f of theta equals cosine of 2 theta, and g of theta is the sum of cosine of theta and sine of theta times the difference of cosine of theta and sine of theta. Find the exact values on the interval from 0 to 2 pi for which 2 times f of theta plus 1 is 0. So it's going to be 2 times cosine of 2 theta plus 1. Let's make sure that I've written this in a way this is the angle 2 theta, plus 1 is equal to 0. All right, well, let's see. If we were to subtract 1 from both sides and then divide by 2, we would get cosine of 2 theta is negative 1/2, which means that 2 theta is cosine inverse of negative 1/2. Well, when is cosine equal to something negative? Well, that's when we're in quadrants 2 and 3. So if that's negative 1/2, that makes this square root of 3 over 2 and negative square root of 3 over 2. That's going to make the reference angle pi over 3. So that makes this answer 2 pi over 3. So 2 theta is 2 pi over 3. And that makes this answer 4 pi over 3. Then, if I were to divide both sides by 2, multiply by 1/2, that's going to give me pi over 3 and 2 pi over 3. To find the rest of my answers, because this was 2 theta, this angle for cosine, that means we can fit 2 full periods in 1 revolution, which means we're going to have twice as many answers as we would have if it wasn't that way. If we add 1 pi to this, we get 4 pi over 3. If we add a pi to this, we're going to get 5 pi over 3. So those are the 4 angles that would make this equation true. B, find the exact value on the interval for which, so this right here is saying this is in quadrant 2, in which f of theta is sine of theta. F of theta was this fella. So when is this going to equal sine of theta? Well, there's different ways to do this. Might be easiest conceptually to get this in all in terms of sine. That's what I'm going to do. I'm going to change cosine of 2 theta into cosine squared of theta minus sine squared of theta. And I'm going to further change cosine squared of theta into 1 minus squared of theta, which means this becomes 1 minus 2 times sine squared of theta. Now, if you recognize from the beginning, if you know this identity, this version of it, and want to go right from there to there, cool. Welcome to do so. If we were to subtract, let's say we get 0 on it by itself on the left. We have 2 sine squared of theta plus sine of theta minus 1. Now hopefully this factors. So I'm going to split the middle term for this and factor by grouping. To do that, I need two things that multiply to get negative 2 times sine squared of theta. That comes from multiplying these two fellows together. Same two terms add to get the middle term of sine of theta. And it looks like that's going to be a 2 sine of theta times a negative sine of theta. So if I split this middle term into a plus 2 sine of theta and a minus sine of theta, that's called splitting the middle term. I'm going to group these two terms together, and the GCF of that is 2 sine of theta, leaving me with sine of theta plus 1. GCF of these two terms is a minus 1, leaving me with a sine of theta plus 1. So I can factor these binomials out to the front and get sine of theta plus 1, leaving me in parentheses with a 2 sine of theta minus 1 equal to 0. If I set each factor equal to 0, I'm going to get 0 equals sine of theta plus 1, and 2 sine of theta minus 1 is 0. I get negative 1 equals sine of theta, and when does sine of theta equal negative 1? That occurs on one revolution as 3 pi over 2, but that's not in domain. So really I'm saying theta is undefined in domain. Because once again, this says up here that it's got to be in quadrant 2. That's not in quadrant 2. Solving this other equation, if I add 1 to both sides, I get 2 sine of theta is 1. Sine of theta is a half. Therefore, theta is sine inverse of a half. When is sine equal to a half? That's in a 30, 60, 90, which is pi over 6. It's not in quadrant 1. So it's pi over 6. This is going to be a half, and also in quadrant 2, this is pi over 6. So that makes this 5 pi over 6. Done a lot of work. Let's make sure I answered the question. I'm also going to try to condense this just a little bit. Find the exact values on which f of theta is equal to sine of theta. So I'm saying the exact value is 5 pi over 6. Part C. To 3 decimal places, find the values of f of pi over 8 and g of pi over 8. All right. Well, f of pi over 8 that's going to be cosine of 2 times pi over 8, which is cosine of pi over 4. I don't even need a calculator for that. That's square root of 2 over 2. If you want to throw that into your calculator to follow the directions, 3 decimal places, that's 0.707. So that's done. G of pi over 8. Let's see if that one is just as simple. Well, let's see. If I look at, before I do that, let me see what part D is before I do that. Yeah. All right, I won't do what I was going to do because part E addresses it, or part D addresses it. All right, so let's just use my calculator. Well, I'll write this out first. So g of pi over 8 is going to be cosine of pi over 8. I don't know what that is. Plus sine of pi over 8. I don't know what that is. Times cosine of pi over 8. Still don't know what that is. Times sine of pi over 8. Still don't know what that is. Put that in my calculator. It's going to give me also 0.707. That's why they wanted me to do 3 decimal places, so you'd recognize that square root of 2 over 2 and 0.707, that's the same thing. It'll end up being the same when the angle is pi over 8. Part D, would your results from part C hold true for any values of theta? Well, in order for us to determine that, we are going to have to figure out, does cosine of 2 theta equal cosine of theta plus sine of theta times cosine of theta minus sine of theta. If this is true, then that is true for all values of theta. If it's not true, then it isn't. And this is the route I was going to go for the previous problem because I recognized they were the same. And I didn't pursue it because the part D said that we want to verify this. So let me show you how I know this is true. We are multiplying 2 conjugates. If you multiply 2 conjugates, you get the first term squared minus the second term squared. I recognize that cosine squared of theta minus sine squared of theta is cosine of 2 theta. So to answer the question, would your results hold true for all values of theta? Yes. My results from part 3C hold true for all values of theta because cosine of 2 theta equals cosine of theta, well, I won't do that because of that work up there. Cool. Is there a part E? There is not. That concludes free response practice 46.